Hi, let me show you how you can find the first harmonic frequency or the fundamental frequency for a closed pipe where the both ends are closed. They have both nodes at the edge and the antinode in the middle. A node is a place where there is no movement of the medium. Antinode is the place where there is the maximum movement of the medium. So with this, we can be able to get the fundamental frequency. So here is the node N, here is the antinode A, and I would like to call this other side N2. So as you're moving from any node to antinode, you have a value of lambda over 4. Let's keep that in mind. So plus another A to N, okay? And this is equal to the length of the pipe. From N to A and from another A to N is the length. Alright, so every node to antinode is lambda divided by 4. Just keep that in mind. Plus another lambda over 4. And this is equal to the length of the pipe. So they have the same denominator. Just pick one of them and add lambda plus lambda. That will be 2 lambda. And this is equal to L. I would like to cross multiply. You can see that 2 lambda is equal to 4L. Then let's divide both sides by 2 to get the value of lambda. So you can see that lambda or wavelength is equal to 4L divided by 2. Therefore, if you divide 4 by 2, you're going to get 2 of L, which is the wavelength is equal to 2L for the first loop. Okay. Alright, so now remember that the velocity of a wave is given as frequency multiplied by the wavelength. And of course, the frequency is the fundamental frequency. I will call it FO, which is the first frequency of the diagram. So here, FO times lambda. Recall that we have already solved for lambda and we got the value here following all these processes. So what did we get when we solved for lambda? We got 2 times L. Okay, so lambda is given as 2L according to what we solved before. So if you multiply these two, you can see that V is equal to, it's supposed to be 2FO lambda, sorry, 2FOL, or FO times 2 times L. So that is the velocity of the wave. Now, I'm going to find the fundamental frequency, which I will call the first harmonic frequency, FO. FO becomes equal to V divided by 2L. So this is the fundamental frequency for a pipe that is closed at both ends. Okay, so we have some situation where they are closed at one end and all that. So let's look at the second harmonic frequency when we have 2 loops. Here I'm going to have another diagram. This is how it looks like. From here to here is still the length of the pipe. So we start identify our nodes and antinode. Here is the node, here is antinode, here is another node, antinode and node. So remember, from N to A, okay, plus A to N, another N to A, then from A to N. Everything here is equal to the length of the pipe, L. So if you add 1, 2, 3, 4, there are just 4 lambdas over 4. So we write 4 wavelength over 4, and that is equal to L. So here you can cancel out the 4s or you just cross multiply. You have that lambda is equal to L. At the second harmonic, the lambda is equal to the length of the pipe, or you can see that the wavelength is equal to the length of the pipe. So understand this. Let's go back to what we have before. V is equal to F lambda, not FL. Then remember that lambda is L, so V is equal to F of L. Okay, so let's get the second frequency, which is F1. Okay, we have found the FO, so F1 here becomes equal to V over L. This is the frequency of the second harmonic. Alright, so let's multiply this by 2 over 2 so that I will have exactly what I have in the beginning. So if you look at this, even if you cancel the 2's, you still get V over L. But why I did this is because I want to get V over 2L, which is what we have in the original derivation. So F1 is equal to 2 multiplied by V over 2L is given as FO. So this is the second frequency, or the relationship between the first frequency and the second frequency is F1 is equal to 2 of FO. Let's try to see if you can get the third wavelength. Here you see that I have 3 nodes in the last one, 1, 2, 3. So I'm going to get 4 nodes in this one. So let's connect the dots. These are the nodes. You connect like this. So identify all your nodes and antinodes. From here to here is the length of the pipe. So let's identify them. Here is the node, antinode, node, antinode, node, antinode, and node. If you combine all of them, you see Na, okay, Na plus An plus another Na plus An plus Na, then plus An. Everything here is equal to the length of the pipe. If you add all of them, they are just 6 in number. It becomes 6 lambda over 4, and that's equal to L. If you cross multiply, 6 lambda becomes equal to 4L. Therefore, lambda should be equal to 4L divided by 6. If you cancel by 2, you have 2L over 3. Okay, so this is the wavelength